Okay, so this is section 2.6. What we're going to be doing in this section is looking at arguments, which we talked about a little bit before, and then we started talking about truth tables, and now we're going to bring them together, right? So what we're going to do is try to determine whether or not an argument is valid or whether it's a logical fallacy using truth tables. Okay, so instead of me just telling you that this thing is a logical fallacy and us trying to sort of like believe it on our intuition, we have a tool that we'll be able to use to analyze an argument and determine objectively if this is a valid argument or a logical fallacy. Okay, so in order to do this, we first have to take the argument and convert it into our symbols for symbolic logic, right? And then we can fill out a truth table for it. Okay. And we'll take a look at that and what in the truth table tells us if it's valid or invalid. Okay, so we'll look at all that. So we're going to look at some examples of some common valid arguments and some common invalid arguments. And at the end is going to be one, extra complicated example just so that you can see one worked out that is maybe more challenging than what you'll be expected to do on your own. All right, so let's go ahead and look at arguments here. So the first thing that we're going to do is symbolize an argument. Remember that when we analyze an argument formally, we're just looking at its form. Okay, so to do that, we symbolize the statements in an argument. Okay, so again, whether an argument is valid or invalid, it doesn't really matter what the specific statements are, right? We don't worry about the context. We're looking at the structure of the argument. Okay, so that's why symbolizing an argument can be really helpful. In addition to kind of condensing things down, it also keeps us from being distracted by the statements themselves. Okay, so let's look at an example. Symbolize this argument. Jasmine must either go to work or find a substitute. She can't go to work today, therefore she must find a substitute. Okay, so in order to symbolize this argument, what we're going to do is first identify the premises and conclusion, because it's important in an argument to sort of understand the difference between those and keep those a little bit separate. Okay, and we talked about having a keyword for conclusions, right? So therefore is our keyword here that lets us know, okay, this thing that follows is the conclusion. So I'm going to write that first. The conclusion is that Jasmine must find a substitute. Okay, that means that everything else is going to be a premise, right? We always just have one conclusion. So our first premise is that Jasmine must either go to work or find a substitute. And then our other premise is that she can't go to work today. Okay, so notice I'm just writing down the statements as they are. I'm not worried about, when we symbolize an argument, how we talk about we always want it to be a positive statement. Okay, we'll worry about that later. Right now, we're just going to write down what are the premises and then what's the conclusion. Okay, so now we're going to symbolize each statement. So we want to identify the simple statements. So for example, our first premise isn't a simple statement because it's an or statement. Okay, so the simple statements, if I read through this, Jasmine must either go to work, so Jasmine must go to work, okay, or Jasmine goes to work, right? I could write that as P. Okay, Jasmine gets a substitute, I can write as Q. Okay. The next premise, Jasmine can't go to work, is just the negation of P, so I don't need a new simple statement. Our conclusion, Jasmine must find a substitute. Again, that's what Q is. Okay. And don't worry if the tense of your verbs is maybe different from one statement to another. We're not going to get too hung up on that. Okay, it's still the same thing. Jasmine's going to get a substitute or find a substitute, or does find a substitute. Okay, so when we symbolize our statements, our first premise, Jasmine must either go to work or find a substitute. Okay, goes to work is P and finds a substitute is Q. So our first premise is P or Q, right? And we want to remember the correct symbol for or. Again, I highly recommend that you just have like a little note card or something that has some of these things on it, for reference, so you don't have to worry about making mistakes. Okay, our second premise, Jasmine can't go to work today, is the negation of Jasmine goes to work, right? So not P. And then we're concluding Jasmine must find a substitute. That's our statement Q. Okay, so to represent this argument, we could say our first premise is P or Q. Our second premise is not P, and therefore we conclude Q. Okay. So we draw a line under the premises, and we use this triple dot symbol to indicate the conclusion, right? So this you could think of as being like a symbol for therefore, okay? But it just indicates that that's the conclusion. And then the line under the premises, again, this is to help make things very clear when we're writing our symbols so that we don't just have a bunch of, P's and Q's randomly scattered on our page and then we get lost. Okay, it's keeping some level of structure to it. Okay. So we've symbolized the argument. Now we have to do something with it. We're going to fill out a truth table, but what we need to do is kind of have an idea for, what it is we're looking for. Okay. So we've symbolized our argument, and now we're going to use a truth table to analyze it. And in order to analyze the argument, what we're going to do is create a truth table showing each premise. Okay. So what we have are two simple statements. So in order to create any truth table that does anything, we're going to need 2 squared equals 4 rows in our truth table. Okay, and so we have a truth table down here that does that. That's already filled out with all the possibilities for P and Q. Okay. So then, in order for the argument to be valid, that means that the conclusion must be true when all the premises are true. Okay, so to determine whether the argument is valid, what we're going to do is examine each row in which all the premises are true and ensure that the conclusion is also true. Okay, so what we're going to do is sort of look at this, slowly and carefully, and then we can maybe speed up for later. But right now what I want to do is I want to write my premises, P or Q. My second premise is not P. Then I'm going to look at my conclusion, Q. Okay, so let's look at the first row. P is true, Q is true. Okay, what I'd like to do is fill out the truth table so I don't have to do two things at once. Okay, so let's first just fill out the truth table for P or Q, okay, for our or statement here. And remember, when we're looking at an or statement, if either one of the pieces are true, then the or statement is true. So true or true gives me a true. Here I have at least one true, so the or statement is true. Here I have at least one true, so the or statement is true. When I have both false, that's when the or statement is false. Okay. Not P is just the opposite of the truth value of P. So if P is true, then not P is false, right? True becomes false. And then if P is false, then not P has to be true. Okay. And Q we already have written down. I'll just repeat those exact same truth values. Okay. So now what we do is we say, all right, we want to look at under which rows do we have all of the premises true. So in the first row, the first premise is true, but the second one is not true. The second premise is false, so we don't have to look at the conclusion. Okay? For an argument to be valid, that means that the conclusion must be true when all the premises are true. But if I have a false premise, then I don't need, it doesn't really matter, right? So the second premise is false, so we don't need to look at the conclusion. Okay, when we talked about a valid argument, we didn't say anything about, what does a valid argument say when your premises are not all true? Okay, it doesn't say anything. So it doesn't matter what the conclusion is if the premises are not all true. So in the second row, my first premise is true. My second premise is false. This is the exact same situation, right? The second premise is false. So we don't need to look at the conclusion. Okay. In the third row, the first premise is true. The second premise is true. Okay, so both premises are true. Okay, and here the conclusion is also true. Okay, in the fourth row, the first premise is false, so again, we don't need to look at the conclusion. Okay, so now let's look at this. Is the conclusion true whenever all the premises are true, right? So in my analysis here, there was only one row in which all the premises were true, and in that case, the conclusion was true. So if I ask the question, is the conclusion true whenever all the premises are true? Here we can answer yes. Okay, so then the argument is valid. Okay, so now we can be sure that this argument is valid. We analyzed it using our... So what were we comparing above? So what we were doing is we were looking at one row at a time, right? So here's the first row. Okay, and what we're doing is looking at, here's the first premise, here's the second premise. If all the premises are true in a valid argument, that means the conclusion must be true. But in the first row, I don't have all the premises true. Okay, so a valid argument doesn't tell you anything about the conclusion when the premises aren't all true. Okay, so I looked at the two premises, they're not all true. So I say, okay, don't worry about it, move on. So now we look at the second row. The second row, exact same story. I don't have all the premises true, so we move on. In the third row, we did have all the premises true, right? When I look at this first premise and I look at the second premise, they're both true. So now I verify, is the conclusion also true? Yes, it is. Okay. In the fourth row, I don't have all the premises true, right? This time it's the first premise that's giving us trouble, right? So then I don't have to worry about the conclusion. Okay. So in every situation where all the premises are true, the conclusion is also true, and that's what makes this a valid argument. Okay. Any other questions about this one? Okay, so what I'd like to do now is look at another example. Okay, this one is called Indirect Reasoning. This is a valid argument. Okay, so I'm just kind of spoiling the ending for you here. So here's an example of indirect reasoning. All runners are athletes. Lydia is not an athlete, therefore Lydia is not a runner. Okay, and this is valid reasoning. Okay, but what we're going to do is we're going to analyze it to make sure. Okay, and it's not that we're not sure that this is valid or invalid. It's not like I read this and like I think that's wrong. What we want to do is we want to go through this process with a simple example that we understand instead of something that's already confusing us, right? Because we're learning this process. Okay, so in order to show that this argument is valid, we'll analyze it using a truth table. So we first identify the premises and conclusions. Okay, so the first premise is that all runners are athletes. Okay, second premise, Lydia is not an athlete. Okay, our conclusion, which is indicated with the therefore, right? So therefore, and now we get our conclusion, Lydia is not a runner. Okay, so this first premise is different than what we had in our last one. This first premise is a universal statement, right, which we talked about a little bit, right? It has this all in here. That was our keyword. So in order to symbolize it, we first need to think of an instance, right? We're going to instantiate it by applying it to an individual. Okay, so in this argument, we're dealing with Lydia. She's the individual we're talking about. Okay, so when we say all runners are athletes, we're going to talk about Lydia specifically. Okay, and remember what we said with these universals is to make all runners are athletes. When we instantiate it, when we talk about Lydia specifically, that means that if she's a runner, then she's an athlete. Okay, so our first premise is going to become if Lydia is a runner, then Lydia is an athlete. Okay, so that's our premise written without the universe, the universal sort of instantiated, so it's converted into an if-then statement. Okay, that means that now we can write our simple statements P and Q. Okay? And if I turn all runners are athletes into the statement, if Lydia is a runner, then she is an athlete, then I can say, all right, I can talk about athletes. So we'll say that P is Lydia is an athlete. Okay. Q, Lydia is a runner. Okay. So now when we symbolize our statement, if Lydia is a runner, so if Q, then Lydia is an athlete, then P. Okay. Lydia is not an athlete, so not P. And then our conclusion, Lydia is not a runner, so not Q. Okay, so that's our truth table written in symbols. Okay, let's go ahead and fill out the truth table then. Okay, so there's our argument in symbols. We want to write down the premises. Oh, we have this filled out differently. I think what I'm going to do is I'm going to back up just to make it match the notes. I think what I did was if we reverse what I have for P and Q, it might fit the notes better. So in our if then runner shows up first, so maybe we'll make that P. So what if I make P, Lydia is a runner, and Q, Lydia is an athlete? Okay. All right, then what would this look like if Lydia is a runner? So if P, then Lydia is an athlete, then Q. Okay. Our second premise, Lydia is not an athlete, so not Q. And then our conclusion, Lydia is not a runner, which is not P. Okay. Now, it doesn't matter which letter you assign to which statement. You could have the original P and Q that I have or flip them, and you don't even need to use P and Q. Remember, we said that you can pick all sorts of different letters. We typically pick lowercase letters from the middle of the alphabet for our simple statements, but there's no hard and fast rules as to which one have to be which. Okay. The reason I'm switching this back is just because we sort of have our notes already pre-structured, and if I write the statements this way, I get an if P then Q. When I had them the other way, I had an if Q then P, and that didn't fit here. So, all right, so here's our truth table. Our first premise, if P then Q, right? We write our second premise, not Q, and then we have our conclusion, not P. So we're going to fill out the truth table. Okay, so remember, and it's a good idea to keep your cheat sheet handy for this, right? A little note card that lets you know. When we have an if-then statement, you can think of it like a promise. It's only false when the promise is broken. So if I have P and I deliver on Q, we kept our promise. That's true. If I have P but I don't give you Q, but I said if P then Q, that's when the promise is broken. That's when we get a false. If we say if P then Q, but we don't have P, then the if then statement doesn't have an opportunity to be made false, right? There's no chance to break the promise, okay? Because we didn't held up the first end of the bargain. So we say, okay, it's going to be true because we didn't have that first part. All right, for not Q, we're flipping the truth values of Q. So the true becomes false, the false becomes true. And likewise, for not P, we take the truth value of P and just flip it. So the true becomes false, and then the false becomes true. Okay, now that we've filled out the truth table, what we're going to do is we're going to analyze all the rows. Okay. What we want to do is look at the rows where both the premises are true. And rather than go row by row each time and write out, okay, this premise is true, this one is false, let's just look at them and say, well, are there any rows where both premises are true? Right? And remember the premises I highlighted in yellow. Okay. So do we have any rows where both premises are true? I'll let my class here participate and chime in. Yeah, we do, right? Which row? The fourth row. So the fourth row, I have P is false and Q is false. That's the only row where both premises are true, right? So it doesn't matter. We're not paying attention to P and Q. We're paying attention to the premises. I have both trues. That's the row I want to look at. And it happens to be that P is false and Q is false. Okay. And in this row, the conclusion is also true. So because every time I have all the premises true, the conclusion is also true, we can say that the argument is valid. Okay. Because in any situation, it doesn't matter anything that we know about Lydia, right? I don't know if she's a runner or an athlete, but I know that the argument is true because under any of the conditions where my premises are true, I have that my conclusion is also true. So I can say that we're guaranteed to have a true conclusion anytime we have true premises. Okay. So we can talk about the form of the argument without knowing anything about Lydia specifically. All right. Does that make sense? Okay. What I want to do is give you some examples of valid arguments. Okay. The first two that we analyzed are going to be on this list, right? So the first one was P or Q, not P, therefore Q. Okay. Which is basically this one, right? So this one was our first example. Okay. Here it's not Q instead of not P, but again, if you just switch all the P's and Q's, you get this argument, right? And so it's kind of the same. All right, the one that we just did was if P then Q, not Q, therefore not P. So that's this one. Okay, so on this list, we've already sort of proved, or analyzed two of these. Okay, what we're going to do is just give you some more examples, just so you can see what some of these are, and we'll talk about them and refer back to them. Okay. The other four, I think, are going to all be proven in the homework. Okay, so you will go through them, but we're just going to talk about them for now. We're not going to go through them all right now. Okay, so I'm going to write down so two names for well, most of these. And these are just going to be ways to refer back to that same argument. Okay, so the first one we can call direct reasoning. Okay, and if you were to study logic, right, and you might do that in like a philosophy class or something, you might refer to these by their proper Latin names. Okay, so this first one is called modus ponens. But we're not going to test you on your Latin in this class, so that's you can think of that as being maybe more for flavor, right? So it's good to hear what some of these things are. You're not going to on like a test or something. I'll just refer to it as direct reasoning. Okay. The second one is indirect reasoning. Okay. Its Latin name is modus tollens. Okay. just to look at these really quickly, the first one is called direct reasoning because I say if P then Q, and we say we have P, therefore we must conclude Q. Okay, so that's our direct reasoning. I have if P then Q, we have the P, therefore we conclude Q. The second one is indirect reasoning because we're starting with that same if P then Q, but we don't have Q, therefore we conclude that we must not have had P. Okay, because if I had P, then I would have had to have Q, but I don't have Q, so I can't possibly have P. Okay. Now, it's not that we're trying to like look at that and think about in our head that yes, that's true. We showed that this is valid using a truth table, so we can feel confident that this is a valid argument. Okay. But I'm just kind of giving you maybe some idea behind why they're called direct and indirect reasoning. Okay. The next one is called transitive reasoning. And the Latin, well, be half Latin. Okay, so it's not really a Latin name for this one, but this is the maybe more formal or proper name. This is a hypothetical syllogism. Okay, and that's why we're going to refer to it as just transitive reasoning, right? Because otherwise, it sounds really confusing. But the reason we call this transitive, if you remember in algebra, your transitive property was if A is equal to B and B is equal to C, then A must be equal to C, right? So the idea of transitivity is that you can create a chain of things. Well, that's what we have here is kind of a chain, right? If P then Q, if Q then R. So if I start with P, right, that'll give me my Q, but my Q gives me R. So if I start with P, I must have R, right? And so that's the reasoning, if P then R. So it's that these if-thens formed a chain. Okay. The next one is called disjunctive reasoning, right? Remember the or statement we said was a disjunction. So this is disjunctive reasoning. Okay, and the formal name for this, disjunctive is already a plenty formal word, so keep that. So this is a disjunctive syllogism. Okay. And the idea is if you have P or Q, right, if I have an or statement and I don't have one of them, I must have the other. Okay. This next one is a little bit more complicated. Okay. And the way that we'll refer to this one is a dilemma. If P, sorry, not if. My first premise, P or Q. If P then R, if Q then S, therefore I conclude I have either R or S. Because my first statement said I either have P or Q. If I have the P, then I'll have R. If I don't have P, I must have Q. And if I have Q, I have S. So in either case, I have either R or S, right? That's the idea behind the dilemma. That's sort of walking through it. Okay. And our last one is a disjunction elimination. Okay, because we voted the or statement off the island. No. So this is a P or Q. If I have P, then I have R. If I have Q, then I have R. So in any case, I'm going to have R. Okay. All right, so these are some examples of valid arguments, right? Reasoning that makes sense. What I want to do is look at an analysis first, but look at what is an invalid argument. Okay, what does that look like when we go through it? So everything we did up until this point, right, all 6 of these are valid. Both of our examples so far were valid. So what we're going to do now is look at something that's invalid. Okay. All right. So we're going to analyze this argument, and I'm letting you know ahead of time it's an invalid argument. If you do the homework, then you will do well on the exam. You did well on the exam, therefore I conclude you must have done the homework. Okay. So let's look at these. And this is actually a really common form of reasoning that, I think people run into. So our first premise is this if-then statement. If you do the homework, okay, then you will do well on the exam. Our second premise, you did well on the exam. Okay, and then we have a nice therefore to indicate our conclusion. So our conclusion is you must have done your homework. So if I want to convert these to symbols, okay, so like the first thing that I read here is, you do the homework. So I'll call that a P. And for Q, right, our next simple statement, you do well on the exam. Okay, and then the next premise we already wrote down is you do well on the exam. Conclusion, you must have done your homework, right? And that's just, the same as our P statement. So we have 2 simple statements. So if I want to symbolize the argument, if, and this first statement is P, so if P, then you will do well on the exam is Q. So if P, then Q. Our next premise is you did well on the exam, that's Q. Therefore, we conclude you must have done your homework, that's P. So this is our argument. If P, then Q, Q, therefore P. So when we want to create our truth table, remember what we want to do is list all of our premises and our conclusion as columns in our truth table. Okay, so my first premise is if P, then Q. My second premise is Q. Okay, our conclusion is P. Okay, so then we fill out the truth table, and we've done this before, right? If P, then Q. So if I have if true, then true gives me a true. If true, then false. Promise is broken, right? So that's when the if then is false. And that's the only time an if then is false, right? Is if we have an if true, then false. If you have an if then that starts with a false, the if then statement is just automatically true. Okay, here I'm just going to repeat the Q truth values. Here I repeat the P truth values. Okay. Now we examine all the rows that make both premises true. Okay. So if I look at these, in my first row, both premises are true. And in my third row, both premises are true. Okay. So let's look at the first row, where P is true and Q is true, right? Both premises are true. And in this row, the conclusion is true. Okay, so that seems fine. Now we look at the third row, and in the third row, I have all my premises are true, right? So in this case, P is false, Q is true, that's the third row. that has true premises, and in this row, my conclusion is false. Okay, so this argument is invalid because when P is false and Q is true, I have that both premises are true, but the conclusion is false. Remember, for a valid argument, anytime you have true premises, you must have the conclusion. And here, it's possible that we can have true premises and not have the conclusion, right? So if I look back at this, what that would mean is if P is false and Q is true, so in the situation where you did not do your homework, but you did do well on the exam, right, then the statement, if you do the homework, you will do well on the exam, is true, and you did well on the exam is true, but you did your homework is false. Okay, so we can have true premises and a false conclusion, so this is an invalid argument. Okay, so just like we sort of summarized up some basic forms of valid arguments and we wrote them down, right, and we worked out a couple as examples, what I want to do is look at some invalid arguments, right? Remember, we sometimes call an invalid argument a fallacy. So these are some common fallacies in deductive reasoning, okay? An invalid form of an argument is called a fallacy, okay? And the one that we just did is called affirming the consequent. And I don't remember if we said that at the beginning. I guess we did it as a title, but okay. So the form of the argument is if P then Q, Q therefore P. So this was our example. Okay, so we'll go ahead and label this. This is affirming the consequent. Okay. Another one that is similar, if P then Q, I don't have P, so I conclude that I don't have Q. That's also a fallacy. That's called denying the antecedent. Okay. Another common form, or another common fallacy. Remember when we had our valid arguments, one of them was that transitive reasoning, where we formed a chain. Here we have kind of the same idea, except that the chain doesn't link up properly. So if I have if P then Q, if Q then R, so that does form a chain, but I take it backwards. I say, well, then if R, then P. Okay, so it's kind of like the same bad reasoning that we had back here, where I have the conclusion, so, or have the consequent, and so then I conclude the antecedent, and that doesn't work, right? So we have the same thing here, except on a chain. So this is faulty transitive reasoning. Okay, and likewise, we can have an or statement, P or Q. I have P, therefore I don't have Q. Now remember, when we started logic, we said that all of our ors, and this symbol specifically, are for what's called the inclusive or, which means P or Q or both. And if I can have P or Q or both, and then I have P, well, I could have Q or not. Either one is possible. So if I say, well, then I don't have Q, right, as a conclusion, then that's bad reasoning. So this is faulty disjunctive reasoning. And again, this one is confusing because in English, the inclusive or and the exclusive or are the same word. They're both just or. In logic, we have different symbols for those two things because they're different things. Okay, so we've got so many words in English, it feels like we could come up with a separate word for those two, but we're kind of stuck with what we have. Okay, so what I want to do is finish by looking at a more complicated argument. So when we were listing these valid forms of arguments, one of these in here was this thing called the dilemma. And so I'm just going to look at that a little bit more closely. And we're not going to go through it. What we've done here is we've just sort of included it here in the notes at the end. But this one is going to be a little bit more involved to analyze. Okay. And the real problem is if you count up the statements, I have P, Q, R, S. We have 4 simple statements, which means we need 2 to the 4th or 16 rows. Okay. And that's a bit much. So this one, I want to have worked out for you, but I don't want to go through that in detail just because that's, too time consuming, right? Too painful, right? We were doing 4 rows and that was plenty to look at, right? 16 seems like overkill, right? But you kind of need that when you look at an argument like this. So here's an example of what this argument would look like in words. So either Jane or Kate will take your order. If Jane takes your order, it will be delayed. If Kate takes your order, it will be incorrect. Therefore, your order will either be delayed or incorrect. Okay. And that is valid reasoning. Okay, we have these 3 premises. None of them are simple statements on their own. Right, we have the 4 simple statements. Jane takes your order, Kate takes your order will be delayed, your order is incorrect. Okay, and so this is what the argument looks like when we write it in symbols, and then we have the truth table for it filled out for you. Okay, and then in order to analyze this, what we have here in the notes, remember for our analysis, we want to look at all of our premises, right? So here's our 3 premises written down. And then we look at our conclusion. And what we want to do is say, well, in which rows are all the premises true? And that's what's highlighted for you, are the rows where all the premises are true. Okay, so here, this one of the premises is false, so it's not highlighted, right? So the highlighted ones are where the 3 premises are all true. Okay, and then you can look at and see, well, in each one of these highlighted rows, the conclusion is true. Okay, so that's how we know that this is a valid argument. If I have all true premises, then we're guaranteed a true conclusion. So this isn't really something that's beyond you, right? You could actually fill this out. It's not really any more difficult than the other ones. It's just more tedious because it's 16 rows instead of 4. Okay. All right. Any questions on this one? Okay, so that's it for today.